Okay, so hey guys, once again most welcome to our YouTube channel Golden Tutorial. So as you know friends, by the thumbnail you are aware that in this video we will particularly discuss about the wave concept, alright, and also solve the MCQ based on wave. Okay, you know friends, wave chapter is one of the most prominent chapter for exam point of view. So you know this chapter is very interesting and very easy as well. Okay, alright, so and we can also say this is extremely important for exam point of view like Air Force, Navy, NDA, and so we cannot ignore it because at least one question from this topic is definitely asked. Okay, so firstly we need to understand the important concept like what is wave and what are the types of wave and some important terminology, right, and some important formulae at which the numerical is asked. Okay, so without getting late, let's start it. So keep this thing, this chapter is extremely interesting and very easy as well. Okay, so how? See, firstly we need to know what is wave. Wave is what? If we have to define these terms in a single word, we can easily say wave is nothing but a disturbance. Wave is nothing but a disturbance produced in any medium. Produced in any medium. In any medium. Okay, if we have to define what is the wave, we can easily define wave is nothing but a disturbance, right? If we define the wave in a single terms, we can easily say wave is nothing but a disturbance, okay, which produced in any medium, right? And also proper wave, keep this thing one mind, keep this thing in your mind. Wave always propagate in a forward direction. Wave always propagate in a forward direction with constant velocity. All right. Now there is another point related to wave. If sorry, condition for the wave propagation. Next title is condition for wave motion. Okay, that means if wave propagate in any medium, then there are three conditions required to propagate. Okay, first one is medium contain elasticity property. That means okay, here we need to understand if wave, for the wave propagation we need to the three properties containing in the medium. Okay, the first property is elasticity property, medium contain elasticity property, and second property inertia property, and third property is less resistance. Okay, if there are three property contained in a medium, then 100% definitely in that medium wave can propagate. If that physical medium does not contain these properties, then in that physical medium wave cannot propagate. Alright, now next item. Alright, what are the types of wave? We cannot say the type of wave. Here we will classify the wave. Okay, we will classify the wave. Now next item is classification of wave. Alright, classification of wave can be classified into two parts on the basis of based on medium, alright, and based on frequency. Alright, based on medium and based on frequency. Okay, now we need to understand what are the types of wave based on the medium. I have here a study about that. There are the two types of wave. First one is mechanical wave. Waves types based on the medium. First one is mechanical wave, and another is non-mechanical. Okay, now what are the mechanical waves? Okay, now we need to understand one by one. Mechanical wave. Which wave? Mechanical wave. Okay, mechanical waves are those waves in which we required medium to propagate. Okay, Mechanical waves are those waves which require medium to propagate. Okay, that means we can easily define this in a simple terms. Required medium to propagate. All right, now it's vice versa. Non-mechanical wave not required medium. Okay, that means if we define the waves, we are meaning two types. First one is mechanical wave, second wave is non-mechanical wave. Okay, mechanical waves require a medium. Right, so mechanical wave required a medium to propagate in a forward direction. Meanwhile, the non-mechanical wave not required a medium, like sound wave, right? Sound wave is a mechanical wave. Meanwhile, light wave is a non-mechanical wave. Why? Because sound requires a medium to propagate. Meanwhile, light wave is not required a medium. Light wave doesn't require a medium for the propagation of wave. Okay, so I hope you understand now. Now we will discuss some important types of wave like transverse wave and longitudinal wave. Okay, see, transverse wave and longitudinal wave. So firstly we need to understand longitudinal wave. Okay, see, longitudinal wave are those waves in which the particle of the medium propagate in the direction of wave. That means, suppose this is water in which wave is propagated in the forward direction, but the particle suppose this is a particle, let us change the color. This is a particle, wave is propagated in the forward direction with the velocity of wave. Okay, and here are the particles, okay, which are oscillating like something this in the direction of wave. Okay, that means here we can easily observe that the direction of the wave and the direction of the particle are same. That means they are parallel to each other. That means theta equals to 0. We can easily say the direction of the wave and the particle of the medium are same. Okay, in another word we can also say this: the angle between the velocity of wave and the velocity of particle equals to 0. Okay, now second thing, transverse wave. Okay, transverse wave are those waves in which the particle of the medium propagate just perpendicular to the wave motion. That means if wave is propagating like something this, then the particle of the medium propagate like something this. Okay, sometimes it goes up and sometimes it goes down. Alright, that means we can easily say the angle between the wave propagation and the particle of the medium equals to theta. Alright, and the wave motion and the motion of the particle is just perpendicular to each other. Alright, now there are some important properties related to the transverse and longitudinal wave, like firstly we will talk about longitudinal wave property. Alright, longitudinal in a longitudinal wave property, there forms compression and rarefaction. Alright, compression and rarefaction. Alright, now the distance between two compression or two rarefaction, the distance is called lambda. Alright, meanwhile the distance between two respective compression and rarefaction or compression is lambda by 2. So keep this thing in your mind. Now same way, now we will discuss about transverse wave property. transverse wave property. See, transverse wave properties. Firstly, in the transverse wave, there forms crest and troughs. Crest and trough. Alright. Now, how the crest and troughs looks like something this. Suppose this is a transverse wave. Alright. This is called crest and this is called trough. Alright. Now, some important terminology. Alright. Oh, sorry. Okay. So come to the point. See. So sorry for mistakes. I'm new on the YouTube, so please cooperate. Now, so there is a extremely important formula which is extremely important for the exam point of view. From this formula, at least one question is asked in, especially for exam point of view. Okay, which formula I'm talking about? That formula is B equals to n lambda. B equals to n lambda. What is n? N is nothing but a frequency. N is what? Frequency. N is what? Frequency. And lambda is what? Wavelength. Alright? This formula is extremely prominent because at least one question is asked from this formula. Okay? How can we write this formula in a different way, like V equals to n lambda, but n lambda, alright? N is what? N is frequency and lambda is what? Wavelength, alright? So keep this in mind, frequency is a constant because frequency never changes from changing one. If wave is propagating from medium 1 to medium 2, alright, then frequency is only one physical quantity which can never be changed. Okay, keep this thing in mind. Alright, frequency is only one quantity, physical quantity, okay, of a wave which never changes from changing the medium. Alright, that means if wave is propagated from one medium to another medium, then frequency never changes. Alright, so now what I want to say from this statement, I want to say V equals to n lambda, because n is constant, then this can be written as this, like something this. This can be written as, here n is constant, here n is constant, that means frequency remains constant. Alright, then this can be written as like something this, that means the velocity of a wave, here V is what? Velocity of a wave, depending on wavelength of a wave. Okay, now see, V equals to n lambda. This implies that V is directly proportional lambda. This implies that V2 over V1 equals to lambda 1 over lambda 2. Alright, this can be written as like something this. V is directly proportional lambda, that means if lambda is increasing, then velocity of V is increasing. Alright, and if lambda is decreasing, then V is also decreasing. Alright, now, so that's about, so that is sufficient. I think that is sufficient concept for the MCQ, solving the MCQ. Okay, so let us start the solving the MCQ. Okay, the first question. So no problem, this question paper in Hindi, but we will also discuss about important terminology. Okay, suppose first question is, which one is mechanical wave? Which one is mechanical wave? Okay, so here option C is the correct answer. How? Now question is raising in our mind, how? Alright, what is mechanical wave? What is mechanical wave? Mechanical wave